All right, welcome to the final section in chapter 4, 4.5, talking about solving linear systems using inverse matrices. Now, the majority of this is going to be done on a calculator, though I will explain it and why it works by hand. Okay, so if you don't know how to put in a matrix on a calculator, you don't know how to do identity, or not identities, but if you don't know how to do um, inverses, I'll teach you in this lesson. But if you don't know how to add and subtract and multiply, probably ask for help, right? So 4.5, solving linear systems using matrices, as I've already said. So this is what brings it all together. This is why we talk about matrices right after we talk about systems. And that's because a matrix can be set up to reflect a system. And I will show you how to do that. So what we're going to do right now is introduce this idea that a couple of matrices can give us something that looks very similar to a system of equations. So let's look and see what happens when we multiply these together. This is a 2 by 2, and this is a 2 by 1. These inside numbers match, so they can be multiplied together, and the result is a 2 by 1. Right, so this is going to be like a 2 by 1. It's going to look like this. So let's go ahead and work it out. This entry being a 2, it's going to be a 2 by 1. So it should be, I'll call this like A, should be like the first row, first column, second row, first column. Okay, so just giving the addresses. So let's do this in green, shall we? So to find the first row, first column entry, you take the first row times the first column. And that's going to give you 2 times x, 2 times this value, which is 2x, and negative 1 times y, minus y. And then for the second one, you take second row, the little 2, second row, first column, second row, first column. And that's going to be 5 times x minus 4y. What does this stuff look like? What does 2x minus y and 5x minus 4y look like? What does the answer look like? Well, it looks something like a system of equations. You don't have to write this down. A system of equations. And that's because it's very close to being one. All you need is the equals and then some number, and now you've got a system of equations. This setup here is what we use to model systems as matrices. So this is all stuff you shouldn't write. This is stuff that I'll be reading right now. Systems of equations can be modeled and solved using matrices. To convert a system to a matrix equation, follow this example. You should write this example down. So here is your system of equations, a perfectly fine one. You've got 3x minus 5y equals 11 and 7x minus y equals 15. Here is how it works. The first row of your matrix here, your first matrix, represents the coefficients of your first equation. So the first row here, the 3 and negative 5 came from here, 3 and negative 5. Then, as you might be able to, extrapolate, the 7, negative 1 came from the 7 and the negative 1 here. Okay? That's a negative 1y, and that's where this came from. Then, the answers went here into their own matrix on the other side of an equal sign, on the other side of an equal sign, on the other side of an equal sign, right? Should be pretty consistent. Then the variables show up in another equation here. And they show up in the order they were presented here. So x came first, y came next, x, and then y, and they go vertically down like this. Okay. So this first matrix is called the coefficient matrix. And the reason it's called the coefficient matrix is because, you guessed it, it has nothing but coefficients in it. The coefficient for the x and the y, coefficient for the x and the y. Coefficients are the numbers that come in front of variables. The next matrix is called the variable matrix for obvious reasons. It has variables in it, the variables you used in your system, and it's in the order that you used them. So x, y, x, y, x, and then y. Then the last matrix is called the constant matrix, the one on the other side of the equal sign. And it is the answers, right? This contains the answers in it, vertically, okay? So, let's go ahead and model this system as a matrix equation. And for any of you who are like, why are we doing this? I will let you in on that secret here in a little bit. So I want to get us familiar with this process first. So here's your system. This is how you model it as a matrix equation. It is a system of two equations and two variables. Two equations, two variables. So it's going to use a 2 by 2 setup. So it looks like this. You've got your three matrices. This is the coefficient matrix. This is the variable matrix. And this is the constant matrix. And the coefficient matrix has the coefficients in it. So it's got -5, -2, 3, and 1. So, sorry if that's making noise. I accidentally hit my my pop filter. -5, -2, 3, and 1. Then, the variable matrix has variables in it, and that's x and y in that order, x and y. And so you get x and y, obviously. And finally, the constant matrix has the constants in it. And that is the answers, 1 and -2. All right, so we have successfully set up the matrix equation. Now, you might be asking yourself, why am I doing this? And I will tell you why right now. If you can figure out what x and y equals in this setup, you have solved this system of equations. Imagine you had a really, really ugly system like this, like -3.75x minus 8.21y equals 6.2 over, and then the next equation is like 11.74x plus 21.3 or 431y equals -0.002. So you got some disgusting, terrible, ugly, hideous system like this. Well, if you can set it up into a matrix equation, which you can, you just basically drag and drop different things different places, you can use your calculator to solve all of it for you. So we typically call this first matrix, matrix A, the coefficient matrix. And then, like all good variables that we need to solve for, we call the variable matrix X, and then we call the constant matrix typically B. So the idea is, if you can get X by itself in this equation, then you know what X and Y is. So what we need to do is we need to get rid of A. The idea is to get rid of A, and the method to do that is what we'll be doing. All right, so this is why we do this. It sets up in this format where once you set this up, there's literally one step you do, and this can be done on a calculator, and then now you know what X and Y is. I love matrix equations because they're such a simple way that students can use to solve all different kinds of systems of equations, so long as, the systems are, they have a single solution. So, let's get into it and talk about how you solve a matrix equation. So, this is a setup for another system, and this is the matrix equation for it. So, I would write down this matrix equation, solving matrix equations, and then write this down. So, AX equals B. So, the step that you want to do is you want to multiply on the left side both equations, or both sides of the equation, by A inverse. A and A inverse will, quote unquote, cancel out, giving you just X. And then over here, you take A inverse times B. and that gives you x by itself. This is the step. So multiply both sides of the equation by a's inverse. This causes a to be eliminated on the left side. So multiply on the left here by a inverse, multiply on the left here by a inverse. Then your solution is x equals a inverse b. You should memorize this. A inverse b. Okay? Because we're going to be using it a lot, and you're going to be seeing it throughout lots of different chapters, lots of different practice sheets. You'll be trying to solve systems, and this way will always work so long as the systems have a unique solution. So, let's go ahead and solve this system of equations using matrix equations. So, let's see. I'm going to go ahead and set this up as a matrix equation. So in our first matrix, we have the coefficient matrix. And that is 2, 1, negative 3, negative 2. And that came from the coefficients. 2, 1, negative 3, negative 2. All right? Then we have our variable matrix, and that is x, y. And then we have our answers, which is negative 5, 2. All right, so we now have our matrix equation. A, x, and b. Now, what we need to do is we need to multiply both sides on the left by a inverse. Now, I'm going to do this by hand to show you that it can be done in case you don't have a calculator. And then I'll show you how to do it on a calculator. So first off, we need to find a inverse. And that was on the last lesson. A inverse is going to equal 1 over the determinant of A times the jumbled up matrix, where these two things flip locations. So you have a negative 2 and a positive 2. And these two things flip sign. So this becomes negative, this becomes positive. And then the determinant of A is the product of the main, because we need that information right here. The product of the main diagonal, negative 4 in this case, because 2 times negative 2 is negative 4, minus the product of the alternate diagonal. So it's negative 4, and then negative 3 and positive 1 make a negative 3. So a negative 4 minus a negative 3, that is a negative 4 plus a 3, which is a negative 1. So it is 1 over negative 1, and that would be just negative 1. So if your determinant is, your determinant of A is equal to negative 4 minus negative 3, which is negative 4 plus 3, which is negative 1. So it's 1 over negative 1, which is negative 1, and then that distributes into each of these things. So when you distribute that in, this becomes positive, this becomes positive, this becomes negative, and this becomes negative. So there's your inverse. So that's really what we're multiplying by. So really that's what we're multiplying by. And that would go over here as well, right? So you don't need to multiply A inverse times A, because the idea here is these cancel. And you just have your x, y, your variable matrix, equaling this product here. Now, this product can also be done by hand. This is the very last thing we're doing before the homework, so I'm going to go ahead and work it out. So you've got, I'll write it out right here, because it's already written down. So this is a 2 by 2 and a 2 by 1, and your answer is going to be, so they can be multiplied because those are the same, and the answer is going to be a 2 by 1. And that looks like this, where there's 2 rows and a single column. So that's where I'll put my stuff. So it's a 1, 1 and 2, 1 are the entries there. And that's going to require me to use the first row, first column, and so 1, 1, first row, first column, and the second row, first column, 2, 1, second row, first column. So this is going to be 3 times negative 5 plus 2 times 1, or 1 times 2. And that gives you negative 15 plus 2, which is negative 13. And then your second entry is negative 3 times negative 5 plus negative 2 times positive 2, which is positive 15 minus 4, which is 11. So you've got 11 and negative 13. So that's what this side over here equals. Don't lose perspective. When you multiplied the right side by A inverse B, that's what this is. Okay. So what this means is that x equals negative 13 and y equals 11. So the answer is negative 13, 11. That's it. So let's see if we get the same answer this other way, using a calculator. So using a calculator to solve, I'm going to go ahead and do the same one here. I know the notes don't say it, but I'm going to. So I'm going to enter this in as matrix A. This is the steps you want to do. Enter this in as matrix A. Enter this in as matrix B. So right now I'm entering this in as matrix B, or A, excuse me. And now going back in and editing matrix B. This time matrix B is a 2 by 1, and it's negative 5, positive 2. So here's how you do it. You're doing A inverse B. So you enter in matrix A, and into the names tab, press enter on A. Then this button right here, the button you've been pressing over and over to enter the matrix menu, is the inverse button. Look, that gave us what we wanted, the little -1. Now we need to multiply that by matrix B. So you go back into your matrix menu, go down to matrix B. Whoa, what did we do wrong? Did I enter something wrong in my matrix? Good thing I checked this. 2, 1, negative 3, negative 2. Oh no. Messing up. No, everything's right, which means I made a mistake here. I'm sure one of my students has caught it. Let's see here. Oh! No, wait, here. Oh, right here. I don't know what happened here. That was a negative 2, and somehow it turned into a negative 3. Wow. Catching mistakes. You know, like I said at the beginning of all of these, I make mistakes. It happens. So this is really a negative 2. So this is really a positive 2, which really makes this a positive 2, which makes this negative 8, because negative 10 plus 2 is negative 8. So this is really negative 8. All right, so this is really negative 8. And that is what the calculator got. Good, we found our mistake. All right, so let's try to do this one. And then we'll be done. This should only take a few more minutes. So the problem with this is that it's not in the right format. You can't convert this into a matrix equation if it's not in the same format, as if both equations are not in this format here. So you need the x and the y, you need it in standard form. You need the x and the y to be together and it equal the number. So what we need to do is we need to subtract 21x on both sides. And that's going to get you 7x minus y equals 8, the top didn't change, and negative 21x plus 3y equals negative 24. So the negative 21x came out plus the 3y. Now you can set it up as a matrix equation. All right, that didn't take so long. It's all the coefficients in one matrix, so 7 and negative 1, 7 and negative 1, negative 21 and 3, negative 21 and 3, and then x and y, your variables, equals your answers, 8 and negative 24. Now, I'm going to plug this in as A and this in as B on my calculator, and this is x, and x will equal A inverse B. I told you to memorize that. This is y. So, time to go ahead and go through this again. Going into the matrix menu, editing, matrix A, it is a 2 by 2. Its dimension, or its entries are 7, negative 1, negative 21, that's 30, negative 21, and 3. Now you change matrix B. Matrix B is a 2 by 1, and it is 8, negative 24. 8. Whoa, I moved my window. Here we go. 8 and negative 24. Now you do A inverse B. So go into matrix, under names, enter in matrix A, press the inverse button, go back into the matrix menu, go down to B, enter that in. A singular matrix. All right, we've arrived at a problem. The problem is matrix A does not have an inverse. Remember, singular matrices don't have inverses. And the reason is because the determinant is 0. What is 7 times 3? Well, that's 21. So the determinant of matrix A, is 21 minus, what is negative 1 times negative 21? Well, that's a positive 21. So 21 minus 21, hey, look, sure enough, that's 0. So this means that your calculator, this is the one disadvantage to using your calculator, is that it cannot distinguish between infinitely many solutions and no solutions. So when your calculator gets a singular matrix error, you need to see if your equations are actually the same equation or if they are like a parallel lines. So here's my advice to you when you're trying to figure this out. All right, look back over here, right before we converted. Look at this. Look for the smaller number where x is or y. 7 and 21. Look for 7, and I mean like the value of the number, not like the sign of it. So 7 and 21, like the absolute value. So what can you do to 7 to make it 21 by multiplying? And that would be multiplying it by 3. So multiply this by 3 all the way across, and you get, what is 7 times 3? Well, that's 21x. This is negative 3y, and this is positive 24. So what happens when you add down is everything cancels. This is a situation in which you've got infinitely many solutions. So that's the answer here. Now your calculator, I'm not going to have you do this, but your calculator could also solve this one. You just pull your calculator out, and instead of entering 2 by 2s right here, 2 by 2 and a 2 by 1, you would enter in a 3 by 3 because you'd have 3 coefficients, 3 rows and 3 columns. So you'd have like your coefficient matrix. You don't have to write this down. And you'd have your x, y, z, and that would equal your constant matrix. And then you would just do the same thing. Let that be A, let this be B. Enter this in as matrix A, enter this in as matrix B. A inverse B is your answer. Here's your homework. Hopefully this has not been too confusing. Hopefully you know how to use your calculator. This is the end of chapter 4. We'll get started on a review soon and review and test. Chapter 3 and 4 are bundled together because they cover the same sort of material, systems, and matrices. I should have already told you about your project that you'll be doing in this chapter. I mean, you guys know the drill by now. How about it?